I'm Matt Saponaro from the University of Delaware. I'm the director of the Technology Service Center. So the presentation's two parts. The first part is I want to kind of overview about a new center that came out of the University of Delaware, that aims at providing technical solutions for external clients. Also, we do work with internal to the university as well. So if we have other UD people here, we are a resource. And then I will present a little bit about some work that I've done in the past. So over at the Technology Service Center, essentially, we're over at the FinTech building on Star Campus. We primarily take our students, we help them to work on projects, and there's always going to be a faculty that's going to help guide those students to solve the project. Those projects tend to be more of like in a consulting capacity, anything within the engineering space. So from software development, from mobile apps to websites, to looking at sensor data, integrating data, creating some dashboards, to creating some type of proof of concept. So anything to help out with the service components of the research. We've noticed that there's a trend, that there is a need to develop some software or have some new sensor that's being created. And not all of it is on the research vein. And so this service unit is supposed to help fill that gap. So we've been doing quite a few projects. We've been working in the sports analytics side. We've been doing parks and recreation, and we've been doing out in just city parks and planning and things like that. But we specialize in AI and more of the applied side. So being able to take videos and processing different things. We created this nice little report for the city of Newark for their trees. And then we again, here's some video processing that we did from a drone to look at the infrastructure, like on equipment. So nice, good old population health type of things. So the students, they'll work on these projects. There's typically a technical lead that is more senior. I play the technical lead often. I come from a consulting background. You may have known me. I actually did a gym presentation last, I think it was about 6 years ago. That's how long it's been, when I was developing my company, AIWU. But now I'm over at the University of Delaware, and we take those same concepts of helping to elevate the students, to help them to get some technical skills, help them to develop some professionalism, but also at the same time to work on projects that are that are of value to the community. So helping to this specific one was helping the UD athletics to, just need to click the button better, helping UD athletics to track their 40-yard dash times. So we can track the person over here, and there's like a little stopwatch that's on the side of here that you don't actually see, that's like recording when the person start and ended on the finish line. And so we got times for each of those players, so that was kind of nice. Um, so, I just wanted to give this a little shout out. So if you're interested in some technological resources, we can provide that. We're coming from the computer science department, but we work with a lot with the engineering departments. We have a lot of AI focus. We have a lot of experience in developing autonomous systems, the vision systems, like I was showing you, some dashboards and analytics, creating some software, creating some mobile apps, things that could help in the research for. And then the last thing that we're trying to do as a result of this center is give our students an opportunity to, if these students work out, they've been vetted, and so they are pretty highly talented. We offer a hiring pipeline, so we'll give you a list of, here's all of our students that are doing excellent, and you can take any students from that list if you'd like. So it's a nice little opportunity. So if you're interested to work with us, you can sponsor a project, you can collaborate us. We will help create a service agreement, state scope of work. You can scan that QR code or go to this website right here, and then you can we'll be in touch, or you can just send me an email. My email's at the end of this presentation. So that's it for the first part. So for the second part, Um, would Aaron, do you think I should give a few minutes of questions, or should we just move on to the full
We
presentation?
can do it all at the end. It just makes it a
Okay.
little bit easier.
Okay, sounds good. So the next step, this is some work that I previously did. My research back in the day when I was doing research was in wearables and trying to deliver smart coaches. So similar to the Apple Watch, kind of like the brains of the Apple Watch, but trying to find that individualized coach and learning what that individualized coach for each person in order to deliver effective nudges to get them to reduce sedentary behaviors. So what we did was we developed this little system to track. We developed this little system to track behaviors over a period of time, and that gave us some baselines to better understand similarities for how much we can reuse information amongst multiple people, and try to identify similarities between different people in order to deliver that smart coach. So the whole entire motivation is that there's a lot of sedentary behaviors that happen, whether it's sitting down in the office for extended periods of time or sitting on the couch on the weekend because you're exhausted. But the issue is that sedentary behaviors lead to heart disease, a whole bunch of other big issues, right? And so we want to try to reduce these sedentary behaviors as much as possible. So sedentary behaviors are just being inactive for a long prolonged period of time. Um, so we have these wearable devices. If you have a Fitbit or if you have an Apple Watch, that really helps. And your smartphones these days, they have step counters and things on that, and that's really helpful because it helps to at least provide some baseline of how much activity you've done for that day. And it has a lot of potential to give like real-time feedback based on the data because you are getting like, every 10 minutes types of information. This graph in the Apple Watch or this is Android, but in the iPhone, the health, the step data updates every 10 minutes or so. So that'll give us really good that's a really good opportunity to provide that, feedback. But what is the type of coaching that we can provide the individual? So, if we look at Fitbit, and I'm going to use Fitbit as my scapegoat, I understand that, Apple Watches are a little bit more sophisticated, but, just giving Fitbits as our baseline, we can always just, improve and improve. But so the Fitbits, it's really interesting, if you got this marathon runner versus this elderly patient, and you strap them with the same Fitbit, and they may get the same type of message. Now, that message, it's first of all, right? Is that really going to help to change the behavior? Questionable, right? Now it is generalized, so like it's kind of weird that like you're giving this marathon runner the same messages as an elderly person. You want to probably individualize that type of, messaging, frequency, context. We want to have it a little bit more personalized because they're going to respond to it differently, right? And now the interesting thing is like this specific one. Now Apple Watch is a little bit different, but the Fitbit, it doesn't really make use of all the data that's actually available. And so we conducted a little experiment. We want to do a just-in-time adaptive intervention, right? Now we didn't do the just-in-time adaptive intervention, but just for clarity, what a just-in-time adaptive intervention is that there's some variables that provide a little bit more context. So it's like, oh, have you been sitting for more than 30 minutes? If you haven't, then do this one. Don't do this intervention option. If you have, then there's some more variables. Maybe you're looking at time of day and then whether you're at home. And based on, this tree or diagram, you're going to be able to specify what is the type of message. Now, we didn't do this, but the goal is, getting that tailored intervention would probably be a better step, right? Than what Fitbit's doing. And maybe if we can better understand how people respond, what this tree structure is, we can actually improve the Apple Watch smart coach as well. So what we did was we did a human subject study. We had 33 people. There was 20 males, 13 females. It was comprised of UD students, faculty, and office workers. We got we brought them in and we collected a whole bunch of demographic information like their age, their sex. We got some initial screening of what they thought their, activity levels were. Any types of, motivational factors, things of that nature. We got their schedule. We asked for their schedule ahead of time. And we basically forced them to wear a Fitbit for a whole entire week. It was the HR monitoring one, the charge HR. And we sent them a push notification on a phone app that we created every single hour from 8:50 a.m. to 8:50 p.m. And boy, that was a lot of information, and it was very painful for the people, but we made them do it. All right. So the content, we basically fixed the content to be the same as the Fitbit, and strictly looked at the context information. So we did, when we're looking at this tree, it's really just looking at, whether they've taken 50 was it 100 steps in the end of the hour. And if they haven't, then we send them a message. But if they have, then we don't, right? But regardless, we sent them a message, but the content was the same, right? And what that allowed us to do was to look at similarities of across the like different people, and try to look at just that baseline understanding of how people, potentially respond. So what we did was create this little app. We basically made them tag a whole bunch of different locations. So, this was someone's home. This was a friend's home. This was the school. This is Smith Hall right here, if you know. This is my house right there, and I think this is one of my coworkers' house. So, and this is my information. So I'm very happy to share it. You can see my little trips going down Main Street looking for food. But anyway, so we had, we also tied it with the Fitbit information. So we got location, geolocation, and we got Fitbit, and then we got this. We sent them nudges every single hour, and the nudge may then like take a 30-second stroll, right? And that was time stamped, and we had the users fill out, where they were in the location, where they were outside, whether they were driving, rate the overall message, what they thought about it, and did they do activity based on this message. So they had to fill out this form every single hour. So, and we basically tied it with the Fitbit, with the geolocation. Now, you may say, hey, why are you asking location again? Well, it's always good to just double check, right? To have, if you have multiple data sources that are telling you, and you get a little bit more reliability. So that's kind of why we designed it that way. Now, there's a few ways that we can measure nudge success in this environment. The first one was, whether they were receptive. So when we sent them a message, did they click in that little form? Did they do activity based on that message, right? Now, it is self-reported, which can be of issue, right? But then, the other way that we can measure a nudge success is looking at the overall impact of the steps. So the number of steps that were taken as a result of the nudge. And these are just things that we can, look at, and we can tie them together. We can look at, say, did they respond yes, and did they do the additional steps, or did they respond no and do additional steps? Like, we have a whole bunch of information that will help us to be a little bit more diagnostic in all this. Now, to get some baseline behaviors, when we captured all the participants, we had 33, how many did I say? 30 some participants. We labeled them 101 to 408, and we looked at their average daily step count. So how many steps on average do they take per day? Fitbit sets their goal of, you have to reach your 10,000 steps. When you look at what, the national recommendations is to have at least 7,500 steps in order to have some impact on your health. So we looked at these two different things. And how many are actually above 10,000? Let's count real quick. 1, 2, 3, 4, 5, 6 people are consistently above, or on average above, the 10,000 step mark. And when you look, I'm not going to count this in front of you, but there's about 15 people that are, below this threshold to meet that 7,500 steps. So, I mean, we're really seeing a very sedentary population in here. Now that does kind of align with, national averages too. We didn't look at the actual agreement, or I need to pull up that stat, but at least it tells you, hey, this 10,000 step goal for Fitbit is probably a little bit unrealistic. So, right. And so, given these unrealistic goals, how does that actually impact for somebody? I mean, if they're constantly failing the goal, I mean, they tend to zone out, right? So that's an issue. So then what we looked at is, are we looking at, so we looked at total time spent at each of the different locations they had, too, because, people labeled them, they labeled gym, home. There was a whole bunch of weird ones that we just categorized as other people put that they were in the park and the work. And we can look at how much time they've been spent in being sedentary in each of these different locations. So it's kind of interesting to see, this is slightly more sedentary. It's about half, but it's slightly more sedentary at home. Whereas this at work, people were slightly more active at work compared to at home. So that's a little bit interesting, right? I think we chose 250. I think that was the threshold. I think I misspoke earlier. 250 was the threshold for, when Fitbit sends that message or not. Now, the other thing, we also looked at whether they were receptive or not. You can kind of see that people were actually less receptive at home, and at work. So it's a little bit less than, more non-receptive over here, right? So. And the interesting thing is, over at the gym, people are just always active. Maybe they took a break or something like that, or maybe they were just sitting on the things and they were doing arm reps or doing leg day, and the sensor didn't actually pick it up. We also looked at, now this graph is kind of weird, but we basically looked at the difference before and after the messages were sent, to see whether there was like a change in steps. And the interesting thing I thought to pull out from here is when we see the moderately active and the more active group, the blue and the green, and we define, most active. If we go back to this initial chat, this initial graph, we basically broke it up into the first, first 30% is in the least active. The next one is the middle active, and the next one is the most active. And when we see this, it's really interesting because when you look at the impact of the nudges, I mean, the more active and the more active people respond more based on those nudges. So it seems like it's really, when we look at the population, you really have to be in that ready state of, mind to be active in order to be receptive of the nudge. So that's kind of interesting. Now, in order to explore this idea of, is there is there an ability to individualize coaching, right? What we did was we basically took everybody's data, grouped it all together, threw it through a random forest classifier, one of the machine learning algorithms, and we built a classifier based on that. And looking at that, and the classification is whether they were receptive or not, right? And so can we predict whether someone is going to be receptive or not based on this contextual information of location, driving, time of day, weekends, steps, whether they were really active or this, and not so active on that time period. And the most important feature is actually the location, which is kind of interesting. And then we have the driving and the time of day are a little bit, are a little bit more important, less important than the location. But it really doesn't matter whether people have walked or not. It seems like whether that's an impact on being able to determine whether whether they're receptive or not. So that's an interesting find. And then I think what we did was we compared that with, what happens if we always sent a nudge versus we use the Fitbit out, looking at the data and just looking at retrospectively the coaching algorithms. And we're going to, always apply the coaching mechanism. We're going to use the Fitbit one. We're going to use that generalized model that I talked about in the last slide. Or if we can use each person's individual model, And I think we split the training and testing set. I think we used like we had them do it for a week. So I think we did like the first 3 days, and that was able to predict the last 4 days. And so the point is that you can kind of see that if you always send a message, it doesn't do it good. Fitbit, I mean, the variance on there is pretty high. Fitbit does more or less the same as the always, so really no impact, I guess you can say, from the algorithm. But using that generalized approach, it has quite a big jump. It's about 15%. Now there are some outliers in here too, and we can talk about that in a second. And it's primarily based on whether people were receptive or not, I think. So there's probably an opportunity to, bin each activity level and create a model within each of those different levels. So that's kind of interesting. And then this last part was we created an individualized model, and we can see clearly, I mean, it just does the best. So that's kind of cool. And then what we did was we just took each individual participant, we took the generalized model applied to them, and we subtracted the performance of the individualized model. The individual minus the generalized model, right? And so if we see a positive thing here, that means that the individual model was better, whereas the red one, that means the generalized model was better. And so maybe I don't recall why these were in better. The generalized models were better, and so we could probably look into it. It could have been that they had an outlier type of week, or maybe I'm not sure. So, okay. So I mean, for the most part, I mean, we're seeing that the individual models just do better than their generalized counterparts. So that's kind of cool. Yeah. Right. And so when we break it out, I think by each, and look at the Fitbit model versus our individualized models, I mean, you can kind of see the accuracy is actually better for the least least active group. Yeah, I mean, that's because it's probably saying no, 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 I think. And that's if I recall correctly, where these people had a little bit more variance. Um, so, right. So this was kind of really cool. This was just a really interesting study that just aggregated all this different information, biometric, geospatial, temporal information to understand the individual's like information, and to just send them messages and see how they respond. It's really cool to see that, it's not cool, it's actually really bad, to see that a large participants were sedentary. So maybe that's an opportunity for us to to improve and to apply these interventions. But it really demonstrates the need to have these tailored or individualized coaching models, because we get a really different behavioral response. So that does, going back to our initial hypothesis, is can we, is there some insight to confirm or validate whether there's individualization or similarities, by breaking up into different activity groups. I mean, we are seeing different behavioral responses within each group, so that leads to us better. There's probably some reuse that's available. Now, the whole entire reason why we want to look at this reuse is because in order to learn, like I think one of the main pain points of the study, which is extremely painful, was that we sent messages every single hour. We can only do that because we paid the people off, because we incentivize those participants. In a commercial application, we're not going to be able to send messages every single hour. So that is one of the main reasons why we'd want to reuse information amongst people that are similar, so that we can, more efficiently, capture data, right? Because if we were to inefficiently capture data, ultimately what may happen is that people may just not wear their Fitbits. So, okay. So I guess I want to say thank you for this opportunity to come here and give this presentation. And I'll open up for questions.